today. Your final is tomorrow?
Yeah.
Okay.
The only thing I really don't understand in this whole study guide is pentagons and using the apothem to find the area.
Okay, let me draw a quick pentagon. It's not a regular pentagon, but it'll do.
All right.
To make the apothem, basically start at the center and connect all the vertices. Now I have 5 triangles, and I want to find this vertical distance of the dotted line. That's the apothem.
All right.
So in order to do that, I usually know a side length. Let's say the side length is 5, or no, let's make it 6.
Okay.
So this is 6, this is 6, this is 6. What I always have to figure out is this angle right there. Because in order to come up with the apothem, I need that angle. So to figure out that angle, I'm going to have to shut off my camera here.
Right.
The computer is complaining. What do I need to do? In other words, if I take this triangle and draw it separately, like this, where this is the apothem, what is this dimension right here?
Would it be 3?
Okay. What is this angle right here?
Is it 30?
Well, it's half of 360 divided by 5 because there's 5 sides to a pentagon.
Half of 360 divided by 5.
Yeah, you see why it's half of that.
Yeah, because the apothem.
Every angle here is 1/5 of 360.
Mm-hmm.
And the angle we're interested in is half of that. So
Yeah.
what is the central angle?
The central angle would be, wait, so 360 divided by 5 is, about 72. So it'd be, 36, right?
No, it'd be half of 72.
Yeah, 36.
36, okay. So this is 36 degrees, and now you can use trigonometry to figure out what A is. Give me the trig function that allows me to solve for A.
Would it be, sine?
No?
Or, no,
sine is opposite over hypotenuse. We do not have a hypotenuse here.
Yeah. It's the cosine.
Cosine is adjacent over hypotenuse.
So tangent, then?
Tangent is opposite over adjacent. So the tangent of 36 degrees equals what?
3 over A.
That allows us to solve for A, because that is just a number.
All right.
So what is A equal to?
A is equal to,
No, I mean, tell me what the next step of this equation is. What is A equal to?
you do tangent 36 over 3 equals A.
No, you got it backwards.
Or 3 over tangent 36?
Yes, make sure you do that algebra correctly.
All right.
And then that you can put into your calculator to come up with a number.
Okay.
Okay. And once you have the apothem, what's the equation for the area of that 5-sided figure?
Is it base times height times 5?
No.
Or 1/2 base times height times 5?
It's 1/2 the apothem times the perimeter.
All right.
Remember, base times height only works on 4-sided figures like parallelograms and rectangles and squares. When you have a more than 4-sided figure, this is the formula. 1/2 the apothem times the perimeter. Well, we just figured out what the apothem was. What's the perimeter if the side length was 6?
Would it be 30?
Yeah. So now we have everything we need for area.
Mm-hmm.
What else you got?
Here, let me look at it. All right, how do you find the area of a regular hexagon? And if the apothem was like, say the apothem was 4.
What's the side length?
The side length is, there is no side length. You're not given a side length.
What else do you know?
That's it. You know that it makes it 90 degrees.
That's fine. So what's the area of the regular hexagon? What's the general formula?
Isn't it,
I just gave it to you.
yeah, is it A equals 1/2 AP?
Okay. So we know A this time, but we
Yeah.
don't know side length, so we don't know perimeter. So we need to figure out side length. Well, side length is that. It's also that. So what can we do? We can draw a triangle. Do we know this angle A?
It's okay. So since it's a 6-sided figure, wouldn't it be
What's
720?
what's the central angle?
Central angle equals
The central angle being this.
would it be 720?
How many degrees are in the whole circle?
360 in this circle.
How many of these angles are there to make up
6.
that whole circle?
Oh, 6. Okay, 360 divided by 6.
So there's your central angle. Now, what is the angle in our triangle that we're looking at? Where we know this side is 4, and we're trying to find x. And what is this angle right here?
Would it be 30?
Okay. So what is x?
X is, so you use opposite over adjacent, or no, you use cosine, right?
No. What relates those two, the x and the 4? You have to figure out which trig function relates the two things that you know. It's not cosine or sine, because cosine or sine relates to the hypotenuse. So tangent. So tangent of 30 degrees equals what?
Tangent of 30 degrees is equal to 4 over x.
No.
X over 4.
The fact that you didn't know that means you haven't memorized this. SOHCAHTOA. Tangent is opposite over adjacent. Adjacent over opposite would be cotangent.
Okay.
Okay, so tangent of 30 degrees equals x over 4, which means x is equal to 4 times the tangent of 30 degrees. What's that number?
tangent over x equals, or no, tangent over 4 over tangent 30 equals x.
No. What have I written right there? 4 times tangent of 30 is equal to x.
All right.
Remember, the tangent of 30 was equal to x over 4. So when you solve for x, it's 4 times the tangent of 30. What's that number? You have your calculator?
Yeah, let me get it real quick. Okay. Okay. So do you just enter that in your calculator?
Yeah. 4 times the tangent of 30.
4 times tangent of 30 degrees equals x.
No.
So
Just type in 4 times tangent of 30 degrees and you'll get a number.
2.309.
Okay. So 2.309 is equal to x. So I can replace this x with a 2.39. Now, what's the area of this regular hexagon?
Okay, so okay, 1/2 of A is 2, so you do 2 times, okay, 2.39 times 6.
No.
Oh.
Remember that this triangle that we drew is only half of one of these triangles.
Oh, okay, so you do 2.
That half right there.
2.39 times 2.
That gives you the side length, okay?
Yeah. Which is 4.78.
Okay.
And then you do 2 times 4.78.
Why 2 times 4 point? Oh, okay, because this was 2. Okay.
Yeah.
Okay.
So the total.
That's not true. The perimeter is not 4.78.
Oh no, you do 4.78 times 6.
All right.
Times 6, which is 28.68. Then you multiply that by 2.
Okay.
Which is 57.36.
Michael, the biggest problem I see is you try to take so many shortcuts that you always miss something. So my recommendation is going to be that you don't take shortcuts. That if you start out with the area equals A times P, well, let's do it one step at a time. 1/2 of 4, and P is the number of sides times the side length. So the number of sides is 6, so we need the side length. So everything needs to be focused on finding the side length. Once you get it, just plug it in and work through this. The problem is that before you get to the side length, you've already turned that into a 2, and then you've done something only half of it, so it's real easy for you to get off by a factor of 2 or whatever. So the best thing you can do is just to take everything one step at a time and plug in one variable at a time. And that way you won't get off. It's like you get in too much of a hurry.
Okay.
Okay? All right. In other words, always start from that equation for your regular polygons, and then know that that's the same thing as 1/2 times the apothem times the number of sides times the side length. This is really what you need to know, because you know the number of sides. If it's a hexagon, it's 6. If it's a pentagon, it's 5. They gave you the apothem, so the only thing we need is the side length.
All right.
All right. What else?
I don't really have anything else. Like,
Okay, that's fine. We can if you're comfortable going into your final, that's a good state. If this was the only difficulties you had was regular polygons,
mm-hmm.
do you want to do something else?
Yeah, can we do one more pentagon problem?
Sure.
All right, sweet.
You want to give it to me, or you want me to make one up?
You can make one up.
Okay, we have a regular pentagon. Notice that this only works on regular pentagons, and I don't know how to draw one, so I draw this one. This is not a regular pentagon. That's a 90-degree angle. That's clearly more than a 90-degree angle. Regular polygons have the same angle throughout.
Uh-huh.
Let me see if I can do a little bit better job of drawing it. Just don't do well with regular pentagons.
Yeah, they're like each
They're
angle.
hard to draw. They're really hard to draw. Okay, do you want an apothem or do you want a side length? You're going to have one or the other. I don't know which you'll run into.
Can I have an apothem, please?
Okay. Find the area of this polygon.
Okay. So you make that into a triangle. You split it into two smaller triangles.
Okay. What's this angle right there?
360 divided by 5.
No, that's actually the central angle. 360 divided by 5 is this one. Notice that the apothem always splits that.
Uh-huh. Okay, so it would be, it would be 36 degrees.
Yes. Because the central angle is 72.
Yeah.
Okay, so now take this triangle and draw it out here so you can see it better.
Mm-hmm.
We know this is 36 degrees.
Yeah.
We know this is 6. So we need this side length. That's not a side length. That's a half a side length.
Yeah.
So let's figure out what that length is before we double it.
So you use trig, which you'd use tangent because it does not include the hypotenuse. So the tangent of 36 degrees equals 6 over x.
Nope.
Or x over 6. And then you set it up to tangent of 36 degrees times 6 equals x.
Okay.
And then I'll do that on my calculator. The tangent of 36, or 6 times.
It's probably easier to do 6 times the tangent of 36.
Yeah.
You may not need that last parentheses if you do it that way.
Yeah.
Tangent of 36 times 6, you definitely need the second parentheses.
Yeah. It's 4.35.
Okay.
Okay, and then...
So what's the perimeter?
So you do 4.35 times 2.
Always.
Yeah, so that's
Because
8.7.
every time we do this exercise, we're always figuring out half of a side length, never the whole side length.
Yeah. So then you do, that equals 8.7 if you multiply it by 2.
Okay.
And then you multiply that by 5.
Okay. And that's your perimeter.
Yep, and then you do 1/2 the apothem, or apothem, which is 3.
No, the apothem is 6.
Yeah, then 1/2 of it, wouldn't that be 3?
Okay, well, see, that's kind of where I'm suggesting you do things different. Don't do this math before you're done finishing the equation.
All right.
Because all that does is it gets you ahead of yourself. In other words, you've already half solved the problem before you've even written it. If you write it fully first, you'll be better off.
All right.
So what's
So
the parameter? What's the
Okay.
perimeter? What we need is a number for this perimeter before we do any math at all.
It's 43.5.
Now you can do all that math.
Okay, so I would say multiply 43.5 and 6.
Well, it's okay to multiply 43.5 times 3. There's nothing wrong with changing that to a 3 now. The only thing I'm suggesting is you don't do this in your head while you're still formulating the thing.
Okay.
From what I've seen, that causes you problems.
All right.
In other words, lay out the general equation and then substitute everything that you know. You know the apothem, so substitute 6 for it, but don't do that math until you've substituted what the perimeter is. Then you can do half times 6 is 3. It'll just work better for you. You won't make as many errors. In general, you know the math pretty good, but you make a lot of arithmetic errors because you get in too much of a hurry.
All right.
All right. Notice that all pentagons are going to have that 36-degree angle.
Mm-hmm.
All hexagons are going to have, what is this angle in a hexagon?
It's okay, so it'd be 360 divided by 6.
That's the central angle. That's 60 degrees.
Then you divide that by 2 again.
So that's always going to be 30 degrees in a hexagon.
Yep.
Or a septagon, I just take 360 divided by 7 divided by 2.
Mm-hmm.
So all of these regular polygons are the same. You have to find the central angle, take half of that central angle, and set it up as this kind of a triangle, where this is equal to half the central angle,
Mm-hmm.
and this is the apothem. If you know half the central angle and you know either the apothem or half of a side, because x is always 1/2 the side length,
Yeah.
then you can solve this triangle. And once you can solve this triangle, you know what either A and P are. You know both of them at that point.
Yeah.
Okay. So pentagons are really no different than hexagons or heptagons or octagons or nonagons or decagons.
Mm-hmm.
Just take that central angle as 360 divided by however many sides there are.
Okay.
Okay?
Yep.
Okay? Is that all you need?
Yep. Yeah, that's really the only thing I had problems with.
Okay. So you're all set for your test.
Yeah.
Let's see. I think today is going to be $14. So this should be the amount due unless I've made a mistake somewhere. Is that right?
Remember last time we only did 2/3 of a session?
Oh, in person?
Yeah.
Okay, let's make this 25. Let's make it all $40. How's that?
Okay.
Okay. Thanks I didn't remember that, but you're right.
All right.
I do remember it now.
Okay.
Okay, so I'm not sure if I have your email or not. I think I do, and I will go ahead and send an invoice for this amount, but that would be your final balance due for this year.
Okay, yeah. I have a check. If you want to, I have a check for 35. If you want to meet up.
No, that's fine. Why don't you just drop it in the mail?
Okay.
Here's my address.
Okay, 1 sec. I just need to write this down. Does that say Quarry Mountain?
Yeah, it's Quarry, and it's just a mountain. It's not a street or an avenue.
All right, got it. Yeah, I'll send that in the mail for you.
Okay, that's good. Good luck on your test, and have a good summer. And you'll probably be taking Algebra 2 next year. If you need any help with that, let me know.
Yeah, of course.
All right?
All right, thank you.
Okay, Michael. Have a good one. Talk to you later. Bye-bye.
All right, bye.